So in this lesson, all I'm going to do is just a bit of tidy up around our code base to make it a little bit shorter, a little bit more succinct, and a little bit easier to read. So the first thing I'm going to do is I'm going to get rid of our debug options. So for any app that you're putting onto the App Store, you probably don't want those dots confusing the user. And the next thing is I'm going to get rid of all these comments and this bit of space, and then inside our touches began, where we create a new dice scene, I'm actually going to separate that out into its own function. I'm going to call it add dice, and it's going to take a single parameter, which is going to be called at location, and this is going to be of the type AR hit test result. Now I'm going to take all of this code and put it into add dice, and then over here instead, I'm just going to call add dice at location, which is the location that we got from our hit result. And this is probably a good point to show you a different way of naming your methods in Swift. So in Swift, there's something called the external parameter and the internal parameter. So we can say add dice at location, which seems quite expressive when we call it. But when we want to use it inside our method, I don't really want to say at location.WorldTransform. Just semantically, or in English, that doesn't really sound good to me. So instead, I want to be able to write something like location.WorldTransform. So I can keep the external parameter as at location, but I can change the internal parameter to simply location. So now I can use location inside the method and still use at location outside the method to indicate what kind of input I'm looking for. And this is just a way of making your code more expressive, so that somebody else who has never seen your code can have a look at it and be able to get to grips with it relatively quickly. All right, so we've separated that functionality out, and I'm going to put this function above the roll all. Now this is really up to you, and this is completely personal, I would say, but I think it makes more sense hierarchically. I'm going to keep these three as they are, and then I'm going to move on to refactoring this didAddDelegate method. So one of the first things you can do is you can add a pragma mark to separate it out, and we'll call this pragma mark AR scene view delegate methods. And now, if you have a look in this drop down, you can see we've got our categories. Our CMU delegate methods, which has only one at the moment. But as your ARKit app gets more complicated, you're going to be putting more delegate methods in here, and it'll be nice to be able to split them up. And equally, you could probably also split up the lifecycle methods up here. View did load, view will appear, etc. And maybe your dice rendering methods. Now you can split this up however you like, but it's just nice when you can actually browse all your methods and properties and have some sort of structure that divides them up. So if you remember, by having that dash in there, you actually get a little line. If you don't have that dash, you only have this bit of text, and I quite like that line separation, so I tend to have it in there. All right, so let's look at this renderer did add method. And one of the first things that you notice that is pretty long-winded are these lines here. If anchor is of the type AR plain anchor, then let plain anchor equal anchor as AR plain anchor. So this obviously is there because I wanted this code to be as expressive as possible so that even a beginner could actually understand what the hell is going on. But now that we're refactoring, let's make this a little bit simpler. So first thing I'm going to do is I'm actually going to take out all of that code, put it at the bottom, and I'm going to comment it out. So right now we're not concerned with that. We just want to shorten all of this junk here. So instead of checking if anchor is of type AR plain anchor and having an else statement that returns, we can actually get rid of all of these lines by simply using a guard statement. So I can say guard let plain anchor equals anchor as AR plain anchor. And if the guard statement fails, then I'm simply going to return. So that single line of code has replaced all of this code, and we can now get rid of it. But before I do that, I just want to show you how it works. So firstly, let's look at this part, we're saying let this new constant plain anchor be set equal to anchor, and we're going to try and downcast it from AR anchor type to AR plain anchor type. Now, if this is not doable, i.e. the anchor that we actually detected was not of the type AR plain anchor or cannot be converted into the type AR plain anchor, then this plain anchor is going to be an optional that's going to be equal to nil. And in that case, this fails, and then this guard statement will jump to the else portion, in which case we return and we escape out of this entire function. So this is kind of like having a moat outside of your castle, where you're tripping up all the things, all the cavalry, all the foot soldiers, and you're trying to prevent them from entering your main code. And you're just saying escape if this statement happens to trigger. So now we can get rid of all of this, and we can bring back all of our code down here. So the other thing I want to do is I actually want a separate method to create that plain. So I'm going to create another pragma mark down here, and let's call it plain render methods. Or plain rendering, I guess that makes more sense. And then I'm going to take all of this and I'm going to put it into a method here called create plain with, and it takes a AR plain anchor as a parameter, and I'm going to paste it in here. So again, I want to have with or with plain anchor as the external name for this method, and the internal name, I'll just call it plain anchor so that we don't have to update our code too much. Okay, so now we're going to call that method over here. We're going to say create plain with plain anchor, and the anchor is of course this one. So let's pass that in there. And then I'm going to make sure that this method actually returns a SCN node, which is the one that I'm going to be adding as the child node. So I'm going to store this inside a constant called plain node. So plain node equals the output of this function. And of course, we need to be able to return plain node here for that to work. And then finally, I'm going to say node.addChildNode, and it's going to be plain node that we got back from that method. And all the errors disappear and all is well in the world. So you can probably even refactor this further. Another suggestion I would make is that this plain can actually be its own object. You can see that we're doing a lot of things on this plain. Plain.position, plain node, plain material, plain geometry. But for now, I'm happy with this, and I hope you enjoyed this bonus refactoring lesson and like the way that our cleaner code looks. If you have any suggestions on future tutorials that you want us to make, then do go ahead and shoot me a message. And we're going to try and figure out what are the things that most people want to learn about and to use it to guide our future course development. So this is all from Angela at the Lunge Apiary, and I hope you'll look forward to more tutorials that we're going to be adding to this course in the coming weeks and months. So thanks for watching this far, and see you soon.